Hello, welcome again. It is Teacher Juma. We are doing metals. This is our lesson 3. So in lesson 3 we are discussing extraction of aluminium. So the chief ore from which aluminium is extracted from is bauxite. But not to forget, we said that in the introduction, lesson 1, aluminium has 3 ores. We have bauxite, which is the chief ore. We have mica, and we have corundum. So mica is a mixture of aluminium oxide, potassium, sulfur. But corundum is basically aluminium oxide. But the chief ore is bauxite, which is hydrated aluminium oxide. The impurities found in this ore are iron 3 oxide and silica. Silica is what we call silicon 4 oxide. Concentration of this ore is by chemical leaching. And as I mentioned also in the introduction, that aluminium makes about 75% of the earth crust, so it is found on the surface. So the method of mining definitely will be open casts, or what we call quarrying. So concentration is by chemical leaching, and here that does not mean that we have forgone all those other steps. Remember, we said generally after mining there will be removing of magnetic materials, washing to remove the gain or the earthy materials, and then we have this part of concentration. So aluminium is not concentrated by froth flotation but by chemical leaching, and as I said, I'll explain more on chemical leaching, giving example of aluminium. So the ore is first ground into powder and then heated. So by heating, the water is lost. So it's just like writing this equation. So by heating here, so you will have the aluminium oxide. We use another ink. So you will have the aluminium, that is the bauxite with 2 water of crystallization forming and the 2 moles of water there. However, this is not pure aluminium oxide. It still contains these impurities. So there is need now to remove these impurities, the further purification now. And this will involve now reacting the ground ore, now this one now, the aluminium oxide, with hot concentrated sodium hydroxide solution. So when aluminium, because it is amphoteric aluminium, so this aluminium oxide is amphoteric, it can react with sodium hydroxide. Remember I said an amphoteric substance is one that exhibits both the acidic and basic properties, or it can react with acids and it can also react with bases. So aluminium oxide is an amphoteric oxide. Also in the mixture we have this one, silicon 4 oxide. This is an acidic oxide. So being acidic, it will also react with sodium hydroxide. So of all the components, so that means this step 1 eliminates this one. Iron 3 oxide is going to be removed. So in the mixture, we will be left with the silica impurities and then aluminium ions. So these are the ones that we are going to have now remaining. So these two will react, forming a solution. So we have 2 reactions taking place. So reaction 1 is this one. So the amphoteric aluminium oxide reacts with the hot concentrated sodium hydroxide. So these are the hydroxide ions from sodium hydroxide, forming aluminate ions, or if you like, this will be what now will be sodium aluminate, because now we have cancelled out sodium ions as spectator ions. This is the ionic equation. So what we are remaining with here, this is what we call the aluminate ions. Aluminate ions. And then silica also reacts with sodium hydroxide, as I've said, The property that enables silica to react is because it is an acidic oxide. It reacts with sodium hydroxide being a base, forming, so this will be silicate ions, or sodium silicate, because again here we have removed the spectator ions, which are sodium ions. So you have silicate ions. So step 3, you filter to remove now this one. So this is at this point now one of the impurities. We had 2 impurities, iron 3 oxide and silica. So at this point, by filtration, iron 3 oxide impurities are removed in form of red mud, or what we call slag. Step 4. Now you need to obtain sodium hydroxide, and there are 2 ways of doing this. One way is either by bubbling CO2, carbon dioxide, that is, through the filtrate. So here you have filtered, you have gotten the red mud and the filtrate. So you can see this is up here, this is up here. So the filtrate contains aluminate ions and silicate ions. Then when you bubble carbon dioxide through the filtrate, it precipitates. So one way is by precipitation of aluminium hydroxide by bubbling carbon dioxide through the mixture containing these 2 ions. Then this will be the equation for the reaction that takes place. So the aluminate ions react with carbon dioxide, forming aluminium hydroxide. Carbonate ions, definitely this will be sodium carbonate, because we have sodium ions here in the solution. So the carbonate ions, which is this sodium carbonate, and then water. Or the other option is seeding process, and seeding is done by adding crystals of freshly prepared aluminium hydroxide in the aluminate solution, that filtrate. So this comes out as precipitate. So in either of the method, so you will have now aluminium separated as aluminium hydroxide, which is solid, or this way solid. That means now you have silicate ions remaining in solution. So at this point, then now you can do the filtration. So in fact, I should have indicated, so after this process, we have the second filtration. So the first filtration, remember, was here. So this is the first filtration. First filtration, then second filtration. So where you are going now to obtain this, so you can discard the silicate, the filtrate. The filtrate will contain silicate ions. You can discard. So this time we will be tracing the residue, which is aluminium hydroxide. So this will be now the residue. So from filtration, now you have that as the residue, and then you will have this as the filtrate, silicate ions as the filtrate. So this one you can discard. You can discard it. You are not interested in the silicate ions. Now aluminium hydroxide is heated or decomposed. Heated at a temperature of about 100 degrees Celsius, it decomposes, forming aluminium oxide and water. Now this aluminium oxide formed now here, this is pure. Unlike this one here, this is impure, it contains the impurities. But this one now here, aluminium oxide obtained this way, is pure. Pure aluminium oxide is then dissolved in molten cryolite. So it is dissolved in molten, so this is already melted, molten cryolite. And then it is melted at a temperature of about 800 to 900 degrees Celsius. It melts, forming aluminium, molten aluminium oxide. Then now the molten aluminium oxide is electrolyzed in what we call the Hall cell. So this is the Hall cell. Remember, sodium was extracted in down cell, but aluminium is extracted in Hall cell. So this is the Hall cell, and this is the setup. So it's just a simple basin like that, which is made up of steel, but the inside is lined with graphite. Then this is what now will be the cathode. The lining will be the cathode, made of graphite. Then we have rods, several rods dipped in. They are also made of graphite. They act as the anode. Then here you have now your mixture, which is molten aluminium oxide and cryolite. Now, why is cryolite added? Just like in extraction of sodium, where we have calcium chloride added, so here in extraction of aluminium, cryolite is added to lower the melting point, of aluminium oxide, from about 2000 degrees Celsius, to be specific, 2015 degrees Celsius. It lowers it to about 800 degrees Celsius. This really reduces the amount of heat energy that will be required to melt the aluminium oxide, thus saving on the cost of electricity. Then, so during the electrolysis process, so the ions present, we have, let me just illustrate that, the ions present in the mixture. The ions present, we have the oxide ions and the aluminium ions. So, oxygen ions having the negative charge be attracted to the anode, which is positively charged, so to the anode, this one. Then aluminium ions be attracted to the graphite lining on the sides. So the oxygen ions, the minus sign means they had gained, so they lose the reverse process. So instead of minus 2 electrons, we take the other side. So we minus 2 electrons. So now these are written 4, but I'm saying 2, because like that first. Then forming an oxygen atom. But as we know, oxygen does not exist as an atomic substance, but molecular substance, the atomic molecule. So 2 atoms combine to form. So first you have it like that. So this loses 2 electrons. But then 2 atoms combine to form a molecule. So that means we need 2 ions to combine. So if one ion loses 2 electrons, then 2 ions will lose 4 electrons. Then the reaction at the cathode, aluminium ions gain electrons, forming aluminium atoms, which is now the liquid aluminium there. Because of the high temperature, the aluminium formed will be in liquid form, like that. Then at this point, you need to balance electrons. The electrons lost at the anode must be gained at the cathode. 4 electrons are lost, 3 are gained. So we need to balance. So we have to balance, so 4 and 3. So here the balancing number will be 12, the mole ratio. So that means 12 electrons should be lost, 12 electrons should be gained. So to do that, so here, multiply here by 3, multiply here by 4. So that 3 times 4 is 12, 4 times 3 is 12. That means everything else here is multiplied by 4, everything else here is multiplied by 3. So 3 times 4, that is 12. 3 times 1, that is 3. 3 times 2, that gives us 6. Then here, times 4, so we have 1 more, so times 4, that will be 4. Then 4 times 3, it is 12. Then 4 times 1, it is 4. So remove that. So this is how the electrons are balanced in this case. So that the overall equation is simply cancel out the electrons, because they are on both sides of the equation, on the reactant here and on the product here. So 12 cancels with 12. Then you add. This is the reactant, this is the reactant. So you have it like that. Reactant. Then this is the product, this is the product. So you have the 2 products. So this becomes the overall equation for the electrolysis process that is taking place here. So here again, questions that can be asked from here: identifying the chief form, and then those steps of purification the purification process all the way up to here. So the 7 steps, starting from the grinding, and then heating to remove the water. Then from there we had dissolving it in hot concentrated sodium hydroxide solution. Filter, you obtain, you remove iron 3 impurities. Then from there, the filtrate, you have to obtain aluminium oxide hydroxide from the filtrate, either by precipitation using carbon dioxide, that is bubbling carbon dioxide from the mixture, or by sieving process, then filter so that you remove the silicate impurities. So the second filtration here, this one removes the silicate impurities as filtrate, which are indicated here. Then from there, the thermal decomposition of aluminium hydroxide to obtain aluminium oxide, then dissolved in molten cryolite to lower the temperature from 2015 to about 800 degrees Celsius. Then from there, electrolysis follows, and this will be the reaction that takes place. So let me just draw a flowchart summary for this entire process for you. So here is the flowchart summary of the Hals process. That is the entire process for extraction of aluminium all the way to the Hal cell. So as we saw in the main steps, so this is now your bauxite. This one here is the bauxite. So bauxite is the ore, the chief ore. Then these two are the impurities that are found in bauxite. That is iron 3 oxide and silicon 4 oxide, or if you like it, silicate. So we say step 1, grind. So the reason for grinding, we say this one increases the surface area. Then heat, you heat to this temperature. This one removes water of crystallization. It removes water of crystallization from the bauxite. So you see it 2 water of crystallization, now it has no water, so that will be step 1. Then step 2, you start removing the impurities. So you dissolve in hot concentrated sodium hydroxide, so in which these two will dissolve, this one will not dissolve. So this one, that is iron 3 oxide, will not react, so will not dissolve. But these two, that is aluminium oxide and silicon oxide, this one dissolves. So they dissolve in concentrated sodium hydroxide, forming sodium aluminate solution and sodium silicate solution. So in the ionic form, this is the one that we had brackets, then minus sign at the top. So just cancel sodium, put the square brackets and minus term, gives you the aluminate ions. So it's sodium aluminate, and sodium silicate. So at this point, when you filter now, completely this one is removed that did not dissolve. So iron 2 oxide removed. So it's removed as red mud. At that point, you have removed the iron 3 impurities. So this is where you have the first filtration. Then now you have the filtrate. So what you have here, this is now what you remain with as the filtrate after the first filtration, removing this. So this is the residue. And then you treat now, you have two options. Either treat with carbon dioxide, the precipitation process, or add crystals of So this one is the precipitation process, or this one which we call the seeding process, that is adding crystals of freshly prepared aluminium hydroxide, which precipitates more of aluminium hydroxide. So you have aluminium hydroxide, while sodium silicate or the silicate ions remain in solution as sodium silicate. So now you have a solid and a solution. So to separate the two, you filter. So when you filter at this particular point, now this one is removed. So the silicate ions, now at this particular point, you have done away with the silicate, with this impurity. So removed as silicate ions. Then now you have your aluminium hydroxide. So our main concern will be is aluminium. So you roast, decompose aluminium hydroxide at temperature of about 1000 degrees Celsius. It gives you aluminium oxide. Then aluminium oxide solid is dissolved in molten cryolite at a temperature of about 800 to 900 degrees Celsius. Aluminium oxide dissolves, forming aluminium liquid. So you have the mixture of aluminium liquid and cryolite. You do the electrolysis in the hard cell, which we just had there. Then you obtain pure aluminium. So this is how aluminium is extracted. So you can get the question in the diagram of the hard cell, or you can have even the flowchart diagram. And all these steps are potential examination areas you can be asked. Then, as I said, the other parts where we have the properties of aluminium and the uses, we shall discuss those ones at a later stage towards the end of this topic. So that will mark the end of our lesson 3. So in next lesson 4, we shall discuss extraction of iron. So thank you and God bless you.